This is lesson 5.8b, is in beta, and this is elementary algebra. And we're continuing on with our examples and applications, and we're on example 3, where we're going to do one with geometry. And we've got a rectangle. It's always good to draw a picture here, just because it wastes some time. The length of a rectangle is 3 more than twice the width. Oh my gosh. Well, how long is it? 3 more than twice the width. Well, how wide is it? Well, we don't know, so we're going to call the width 8. So if the width is 8, and it says that the length is 3 more than twice the width. What is twice the width? 2x. And how long is this? It's 3 more than twice the width. Okay, so that is the hard part. Alright, the area is 44 square inches. Find the dimensions, find the length and the width. Okay, what do we know about area? Area is always length times width. And I know that that length times width is 44. So if I multiply this times this, I'm going to get 44. Okay, so I'm looking for x. So I'm going to multiply by distributing. Got to set it equal to 0. Can't have a number over there. Got a 2 here. And remember, whenever you have a number there, you can't just make 2 parentheses. You have to first of all multiply this times this and get negative 88, and find two numbers that when you multiply together give you negative 88, added give you 3. So what are the factors of 88 that I can try? 2 and 44, I can't add those and get 3. 22 and 4, 11 and 8. Difference between those is 3, so that is what I'm going to use. So I'm going to, whoops, I can't have this here. I can't erase it, so this goes away. Remember, we have to group and all that stuff. So instead of a 3x here, I'm going to write this as 2x squared minus 8x plus 11x minus 44 equals 0. So again, remember, I replaced my positive 3x with that. I just split it up and made it that. Because when you add these two together, you're going to get 3x. And notice how I put my 11 over here instead of over here so that this is a plus sign. Remember, it makes it a lot easier. What happened there? Okay, so what I have is 2x squared minus, I'm just going to rewrite this and then move some stuff up so that I've got some room to work since I'm running out of chalkboard. And we'll see what I can move up. I can move most of my stuff up there, can't I? Okay, let's move this back down. I want to be able to look at that. Okay, so I'm concerned about what's in the blue. Alright, so let's group. What can I factor out of there? I can get a 2 and an x. That's common to both of those, and I'm left with x minus 4. If I multiply this back, I get 2x squared minus 8x. So I get back, if I multiply, I get back what I had. So I factored out a 2x. Alright, let's see what we can factor out over here. Well, 11 goes into 11, and 11 goes into 44. So I can pull an 11 out. I've got an x. 11 goes into 44 how many times? 4 times. Okay, so I've got that. Now I put these two together. And these two. Okay, so then I split them up. And this one is the trickier one. And then I divide by 2. That doesn't look so happy. And this one over here is going to be 4. So there's my two answers for x. Two possible solutions there for my x. Alright, do you see a problem with this here? I mean, it worked. I got an answer. But what does x represent? It represents the width. Can you ever measure something and get a negative value like we did here? No, you cannot. Lengths and distances are always, always, always positive. So that means this isn't, I mean, it's an answer, but it doesn't work. But this one is positive, so let's see if it works. So we're going to put a 4 here, and a 2 times 4 plus 3 here. So this would be 11. Alright, so what does the question ask? The length of a triangle is 3 more than twice the width. Alright, we don't care about that. The area is 44. When I multiply 4 times 11, do I get an area of 44? Yes, I do. So that means my length is 11 and my width is 4. And I'm done. Okay, looking at example 4, we've got a square. The numerical area, or the answer of the area of a square, is twice its perimeter. What is the length of its side? With a square, I know that both of these, or all 4 of these, are x. Okay? And I know that when I add all the x's up, I get the perimeter. So 4 x's is the perimeter. And area would be x times x, right? And I know they aren't equal to each other, but I know this one is the area and this one is the perimeter. Okay, because it's saying that the area of the square is twice the perimeter. So are they equal? Can I say that they're both equal? No, because it says the area is twice as big as this. So if the area is twice as big as this is half the size of that. Well, I don't want them to be different. I don't want this one to be half the size of that, or this one to be twice as big as this. I want them to be equal. That's why I have an equal sign. So in order to make them equal, if this one's twice as big as this, if I make this one twice as big as it is, now they're equal, right? So 8x equals x squared. So how do I find x? Again, I set it equal to 0. I'm going to flip them around because it doesn't really matter. You can take this and move it to the other side. Then I'm going to subtract 8x from both sides and set it equal to 0, because that's usually what I do, is I make it equal to 0. Then I think, okay, can I factor anything out of there? Well, yeah, I can factor out an x. Okay, so now I have two parts to this, that part and that part. So either x is 0 or x minus 8 is 0. Well, if x is 0, I don't have a square, do I? Because I'm saying that these sides are 0. And if there's no length to them, then it doesn't exist. So we're going to throw that one out. If x minus 8 is 0, then x has to be 8, right? So if x is, it's supposed to be an equal sign, 8. Let's see if it answers our question. The numerical value of the area of the square is twice its perimeter. Well, let's look at the perimeter here. 8 plus 8 plus 8 plus 8. That is 32. That's my perimeter. What's the area of this? 8 times 8 is 64. It says my area is twice my perimeter. Is that true? Is 64 twice 32? Yep. So that means I was right. X, the length of my square, is 8. Oh, there go those doggone sirens again at 7:30 in the morning.